A 1.5 kilogram pendulum bob swings from the end of a 2-meter long string. The maximum angle from vertical reached by the pendulum is 15 degrees, and the bob reaches a speed of 1.16 meters as it passes through the lowest point. What is the force exerted on the bob by the string at the maximum angle? So the pendulum is swinging back and forth like this. So the center of the circle is up here. So this is pointing towards the center. The distance from here to here is the length of the string. That is 2 meters. And also the angle they give you is from vertical. So it's this angle here, which is 15 degrees. Okay, so the pendulum's swinging back and forth. It's at its highest point here. And if this is the highest point, it's going this way, then it's turning around and going this way. At the highest point, the velocity is equal to 0. So we are going to sum up the forces acting in towards the center of the circle, and that is equal to mv squared over r. We have a force of gravity acting straight downwards, and we have the force of tension acting in towards the center of the circle. I have to break this force of gravity down into components because I want the component which is acting in the radial direction. If this angle is 15, this angle is also 15 degrees, and I have mg cosine of 15 degrees, and then acting this way I have the sine component. So if I'm only concerned with the forces acting in the radial direction, when I sum up the forces acting in towards the center of the circle, I have t minus mg cosine of 15 degrees is equal to, v is equal to 0 because we're at the highest point. So therefore I have t is equal to mg times cosine of 15 degrees. The mass is 1.5 kilograms, so you can plug the numbers in, and for the tension you should get 14.2 newtons. And then we want to know what is the force exerted on the bob by the string at the lowest point. We have tension acting upwards, we have the force of gravity acting downwards, the pendulum swinging back and forth like this, in towards the center of the circle is upward. So I have the sum of the forces acting in towards the center of the circle would be t minus mg, and this is equal to mv squared over r. I was told that at the lowest point the speed is 1.16 meters per second. Let's bring the force of gravity over to the other side and say t is equal to mv squared over r plus mg. I can pull out the m, and then I have t is equal to 1.5 kilograms. V is equal to 1.16 meters per second. We'll leave the units out. This is squared divided by the radius, that's the length of the string, which is 2 meters, plus 9.8, and this gives me 15.7 newtons.